a converging lens. Dear children, this is a biconvex lens. Bi means two surfaces. So convex means the bulged side outside. So the name of this particular lens is known as a biconvex lens. If you see the shape of the biconvex lens, it is in the middle and thinner at the edges. You can see clearly the biconvex lens is thick in the middle and thinner at the edges. So different type of convex lenses. The first one is a biconvex lens and the second one is a plano-convex lens, because one surface is a plane one and the other surface is convex. So it is a plano-convex lens, and this is a concavo-convex lens. So these are the three different kind of convex lenses. Dear children, see how a biconcave lens will be. This is a biconcave lens. The two surfaces are so you can see, as far as biconcave lens is concerned, it is thin in the middle and it is thicker at the edges. Dear children, I think you might have identified the difference between biconcave lens and biconvex lens. Now type of concave lenses. The first one is biconcave lens, plano-concave, because the one surface is plane, the other one is concave surface. This is convexo-concave surface. Dear children, now we are going to see how a biconvex lens is going to form. The biconvex lens. So this is a sphere and this is another sphere which is hollow, and the region where the two spheres, you can identify clearly, the white portion is a biconvex, and this is the midpoint of the biconvex lens. The point is known as optical center. C1, C2 are the centers of the actual spheres, and this is a principal axis. These two are the radius of curvatures. Now you can see, children, here we have the outer surfaces of the two spheres. This is one part of a sphere and this is the another part of a sphere. So for this sphere, this is the center, which is C1, and for this sphere the center is C2, and this is the center for the biconvex lens. Dear children, see here, this is a sphere again and this is also a sphere, and if you arrange the two spheres in this way, the portion which is in between these two spheres, which is technically cut from the two spheres, is in the shape of a biconcave lens. So this is the center of the biconcave lens, and R1, R2 are the radius of curvature of the biconcave lens. Now we are going to define what is center of curvature. So this is a biconcave lens, a biconvex lens. The center of sphere which contains the part of the curved surface is called center of curvature, radius of curvature. Here the two spheres, and this is the biconvex lens, and R2, R1 are the radius of curvature. So the distance between the center of curvature and curved surface is called radius of curvature. The line, this is the line joins C1 and C2. The line which is red in color, the line joining C1 and C2 is called the principal axis. This is the formation of biconvex lens, and this is the white region is a biconvex lens, and the midpoint, this is known as optic center. So the midpoint of thin lens is called optic center of the lens. Dear students, so this is the different terms of biconvex lens. Dear children, see the activity clearly. Observe this video clearly. So light rays are coming parallelly, and if you place a magnifying glass at particular point, you can see that the paper is burning when all the parallel light rays are focused on the magnifying glass. In this activity, if you focus the magnifying glass and it is exposed to sunlight on a white paper, you can see, children, that the paper is burning. Why? What could be the reason for this one? You can see clearly, when a magnifying glass is exposed to sunlight, it can burn a piece of paper. You can see the paper now. Now, dear children, what is the reason for the above action and above video? What could be the reason for the previous two activities? The light rays are converging at one particular point. So now we are going to see the convergent action of convex lens. This is a convex lens, and all these light rays are parallel light rays. In that activity, these light rays are going to resemble the light rays which are coming from the sunlight. And after refraction, all these light rays are going to focus at one point. So this is the convergent action. This is the reason for that activity, and the point where all these light rays are going to meet is known as focus, which is known as principal focus, and the line passing through the principal focus is the focal plane, and the distance between optical center and the focus is known as focal length. So the distance between the focal point, this is the focal point, and the optic center, so this is optic center. So the distance between optic center and the focal point is known as focal length. See the activity, dear children, see this video clearly. So these are the two laser light beams, and if a convex lens is introduced in the path of those two parallel light rays, you can observe clearly that these two light rays are converging at one point. So this is the convergent action of a convex lens. The convergent action of convex lens, the light rays which are parallel but not parallel to principal axis. Children, you can see all these light rays are parallel but not parallel to principal axis. Light rays are parallel means they are coming from infinite distance, where these light rays are going to meet. All these light rays are going to meet at one point. Again, this point is also known as focus, but this focus is not on the principal axis. The reason is these light rays are not parallel to principal axis. They are parallel but not parallel to principal axis. So the point where these light rays are going to meet is known as focus, and the line AB is passing through the focus, and the plane consisting the line AB is known as focal plane. Again, the distance between optical center and the focus is known as focal length. Dear children, what you can see in this picture, this is a peephole which is arranged to a door. What is the purpose of this type of materials? You can see the wide view. So how does a door peephole give a wide view? You can see outside view through the peephole which is arranged to a door. What could be the reason for this one? See the activity. these two are the parallel light rays. If you keep a concave lens in front of these two parallel light rays, what you can observe? They are diverging, they are not converging, they are diverging. So, a concave lens diverges the light rays, which is especially a parallel beam of light rays, are diverged when a concave lens is placed in front of a parallel light beam. Now you can see the divergent action of concave lens. This is again a parallel beam of light, and after refraction all these light rays are diverging, because we saw in the previous activity the light rays which are parallel to principal axis, they are diverging when they pass through a concave lens. So where is the focus? Can you get a real focus here? Yes, here we cannot get the focus really. The focus is going to form when we retraced all these light rays backwards, so that all these light rays appears to be coming from this point. So these light rays appears to be coming from this point, and this point is known as focus for a biconcave lens, and this is the line which is passing through the focus. The plane consisting this line is known as the focal plane for concave lens. Now diverging action of concave lens if the light rays are not parallel to principal axis. So these light rays are not parallel to principal axis, they are coming from infinite distance, and dear children, where all these light rays are going to meet again? Will they meet? Let us see. Oh, these light rays are diverged because of the action of concave lens, because the nature of concave lens is not convergent, it is divergent. So where you can get the image? Can we get the real image? No. So in this type of situations, extend these light rays so that all these light rays appears to be coming from one particular point, that is the focus in this situation. So dear children, all these light rays are again coming from infinite distance, and after refraction they are parallel to the principal axis. Now these light rays appears to meet at this point. This point is also known as focus for a concave lens, and the line passing through that focus and which consisting the plane is known as focal plane. So dear children, now how we can get the image when light rays are passing through a lens? For that, at the time of refraction and at the time of reflection at curved surfaces, we discussed some rules. Here also we are going to discuss some rules which are going to help in the drawing of image formation when the light rays are passing through the lens. So let us discuss the first rule. When the ray travels parallel to principal axis, this is a convex lens, a biconvex lens. F1 and F2 are the principal focus, and 2F1, 2F2 are the distances which are double to F1 and F2, and this is the light ray which is parallel to principal axis. Children, see, this is the light ray which is parallel to principal axis. Can you able to tell after refraction how this light ray is going to refract? Yes, this is going to pass through the focus. So after refraction the ray passes through principal focus. See the next picture. This is second rule. When ray passes through optic center, what happens? If a light ray passes through optic center, is there any deviation? Good. So if a light ray passing through optic center, there is no deviation for this light ray, it passes undeviated. So ray passing through optic center is undeviated. Let us see the next rule. when ray passing through focus, if a light ray passes through the focus, then after refraction it passes parallel to principal axis. So a ray passing through focus will take a path parallel to principal axis. This is also a light ray passing through focus. After refraction it is parallel to principal axis. You can see in case of concave lens also, if a light ray is parallel to principal axis, then after refraction it has to be diverged. So if you extend this light ray, it appears to be coming from the focus. Dear children, how we can see the images through the lenses? In the previous class also we discussed we can see beautiful images through the lenses. So in order to discuss how the images are going to form, now we are going to discuss how images are going to be traced with the help of ray diagrams. So now we are going to discuss how ray diagrams are going to be traced. This is a convex lens, an optic center. Dear children, you can see here a scale is there. You can fix 2 points F1 and F2 which are principal focus at equal distance from optic center, and this is at 10 centimeter mark and this is at 20 centimeter mark from the optic center. So these two are at equal distances. 2F1 and 2F2 are the distances which are at 5 centimeter mark and 20 centimeter mark. So before going to draw the ray diagrams, mark F1, F2, 2F1 and 2F2. Now see the first ray diagram. When the object is at infinite distance, this is a biconvex lens and these light rays are parallel to principal axis. So when the light rays are parallel to principal axis, then object is said to be at infinite distance and all these light rays are going to meet at one point. That point is focus and the image is real, inverted and point size image. So children, can you able to tell where we can use this phenomena? Yes. So in case of magnifying glass, this is the phenomena used. The phenomena used is light rays are parallel and they are coming from infinite distance which are going to converge at one point which is known as focus. When the object is beyond 2F1, this is a biconvex lens. You can see F1, F2 are the principal foci and this is the object which is beyond 2F1. Dear children, you can see this is the object which is beyond 2F1. Now how to draw the image for this object? Minimum 2 light rays are required to get an image. So already we discussed the rules. Let us draw one light ray which is parallel to principal axis. According to rule 1, after refraction it has to pass through the focus, and draw another light ray, second light ray which is passing through optic center. Is it going to deviate? No. In which path it is going to move? It is going to move undeviatedly and these two light rays are going to meet at this point. This is the point where these two light rays are converged. So this is the point where you can get the image. So this is the image. Now you can see the image is real, image is inverted, image is diminished. So in photographic camera we can use this concept when the object is beyond 2F1. When the object is at 2F1, this is a biconvex lens, children, and if the object is at 2F1, similarly we are going to follow the same procedure. One light ray parallel to principal axis, after refraction passing through focus, second light ray undeviated which is passing from optical center. This is the image. You can get the image which is real, inverted, diminished. This is used in photographic camera. Now dear children, when the object is between 2f1 and f1, this is a parallel light ray passing through focus, and another light ray. These two light rays are going to meet at this point, which is real, inverted. Is it diminished or magnified? It is a magnified image. So this is used in telescope. So this phenomena of getting image is used in telescopes. So dear children, what happens when the object is located at the focus? See, this is a biconvex lens, and if the object is at the focus, these two light rays are not going to meet at any point. So then what happens? So the image is going to form at infinite distance. So these two light rays are going to meet at infinite distance. That means at far away these two light rays are going to meet. So in this case the image is real, and it is going to be inverted and highly enlarged image, and it is used as a searchlight. This concept is used in searchlights. When the object is between O, that is optical center, and f1. So the object is between optical center and f1. Now draw the light ray which is parallel to principal axis. It passes through focus, and this is the second light ray. These two light rays are not going to meet, and again they are not going to give the real image. So in this situation, extend these two light rays backwards, so that these two light rays appears to be coming from that point, so where the image is going to form. So you can see children, this image is highly enlarged image, which is erect image, virtual image, and it is erected. So the use of this phenomena, we can use it in simple microscope when the object is at infinite distance for a concave lens. So light rays are parallel and diverged. This is the focus. Image is virtual, erect, and diminished to a point, and this phenomena is used in eye lens in Galilean telescope. So for a concave lens, when the object is at any position, this is a biconcave lens, and if you place an object at any position, you can take at any position irrespective of the position of the object. Take a light ray, this is refracted, extend backwards, and optical center, light is passing through optical center, and these two light rays appears to be meet at this point. So this is the image which is diminished image and erected image. You can see now this is virtual image, because virtual images are always erected, so it is an erected image and diminished image. So this concept is used, the remedy of short-sightedness. With some examples, see example 1. Draw a ray diagram to locate the position of image when a point source is placed on optical axis Mn of a convex lens in such a way that it is beyond focal point f2. Dear children, this is a convex lens and principal axis. Mn is the principal axis here. So in the question it is given, draw any ray diagram to locate the position of the image when a point source is placed on optic axis. So this is the point source and focus. So this is the situation given in the problem. In this picture, this is a convex lens and Mn is the principal axis, S is the point source, F2 is the focus, and O is optic center, and F2 is optic center. Draw a normal to principal axis at F2 and take a light ray which is passing from the point object at O dash, and draw a parallel line to this line which is passing through optical center. Now after that, if you draw a line to this parallel line, which is going to meet the line which is drawn from the focus at this point. So this is the refracted light ray which is going to meet at f0, and where the light ray is going to meet on the principal axis is the image for that point source. So dear children, you can see this is the source of light, and draw any line from the point source and draw another line which is parallel to this line and passing through O, and this line is going to meet the line passing through the focus at this point. So draw the line which joins O dash and this point. So this line is going to meet the image at this point. Dear children, so let us recollect what have you learned today. So in this session we learned lenses and their types. Convex lens acts as convergent lens, concave lens acts as divergent lens, and the images for the objects which are placed at different positions. When the object is at infinity, image is at focus, and when the object is beyond 2f1 and it is real and inverted, and at 2f1 the size is equal to that of the object, and it is between f1 and f2f1, the image size is enlarged, and if the object is at the focus, the image is highly enlarged, which is real and inverted. Between focus and optical center, it is erect, virtual and enlarged. So dear children, you try to answer these questions, improve your learning. You can see three different colors in this biconvex lens made up of three different materials. A convex lens is made up of three different materials as shown in the figure. How many images does it form? Try to draw the ray diagrams for the following positions and explain the nature and position of the image. When the object is placed at C2, object is placed between F2 and optic center O. Third question. The figure below shows that ray AB that has passed through a divergent lens construct the path of the ray to the lens of the position of its foci is known. Dear children, I hope that you understood well, and you can refer the NCERT website to solve the worksheets after the completion of this lesson. Thank you. Let us meet in another wonderful session of refraction of light. Thank you.